All right, so this is AP Calculus Self-Check 8.1. We have the Mighty Cable Company, and you'll be seeing this. This is from the 2009 normal scoring guide for question 3. It's version A, I guess, not version B. Let's go ahead and mark up what's going on. So if I'm selling for $100, 120 per meter, that is my positive rate. I'm gaining money, and then I have to spend money. This is my negative rate here. The 6 square root of x is my negative amount of money, and that's all per meter. So find the profit on the sale of a 25 meter cable. So I'm doing the integral between 0 and 25 of the positive minus the negative. So it's going to be 120 minus 6 square root of x, all of that dx to be formal about it. So when I do that, I don't like thinking of it as x. I'm thinking of this as x to the 1/2. And I can zoom in here so I can see it a little bit better. I'm taking the antiderivative of 120, and that's going to be equal to 120 x. And there's a few different shortcuts that I could be doing. Like I could be doing separating it in an integral of just 0 to 25 of 120, and then using the shortcut 25 minus 0 times 120. I'm going to do it kind of the long way. Did you guys do the shortcut or the long way?
I didn't set it up right.
Okay. Stego, Claire? Claire? Okay, I'm going to continue doing what I'm doing. So I'm going to do minus 6, and then this was x to the 1/2. I'm going to go up a power to the 3/2, and then I'm going to divide down by 3/2, so I'm going to put 2/3 out front. So let's put the times 2/3, and that's going to be evaluation bar between 0 and 25. From here, we get to actually plug some things in. Notice when I plug in 0, if I'm looking ahead, I normally plug in 25 first, but if I plug in 0, it's going to be all 0, so I really only need to plug in 25. When I plug in 25, I have 120 times 25 minus, and then this is going to cancel some things. So the 6 and 3, that turns into a 2 on top, and that's really a 4. So I have 4, because 2 times 2, and then I have times 25 all to the power of 3/2. And that sounds a little bit hard, but remember that whenever I have 25 to the 3/2, I can come over here. 25 to the 1/2 to the power of 3. That's the same thing as 25 to the 3/2.
So what happens when you multiply 25 to the power 1/2?
25 to the 1/2 is the same thing as the square root of 25 all to the power of 3. And the square root of 25 is 5, and 5 cubed is 125. So this is equal to 125. Sego, you're comfortable with that? Geo, comfortable? Claire? All right. So I come back over here. So this is now going to be, I'll go to yellow for an intermediate step. This is going to be equal to 120 times 25. Is there a cool way of thinking about this?
240.
Well, I know every 4 25s is 100. And how many 4s do I have in here? I have 30. So I have 30 100s. So I think 3,000 is what I got. You got that, Claire? Cool. And then minus 4 times, and then 25 to 3/2, we just discussed that, is 125. 125. And 125 times 4 is 500, so minus 500. And finally I get 2,500. And don't forget our units. It doesn't say to, but I'm going to put them just so we don't forget if we eventually needed to. We get dollars. That's our profit. Final answer, box it. How do we score ourselves? In terms of the solution guide for the 2009 AB test, yes, we got the correct answer. Whew! All right, if you set up the integral correctly, so this integral right here, notice that they did it a little bit differently. But if you have some sort of integral with the correct bounds and the correct integrand, the inside part, then you get a point. So back over on mine, I got a point by doing this right here, +1. And I got a point for saying, I think it was the answer, right? For the answer, yeah. The answer of $2,500 plus 1 point. So this one was just out of 2. All right. What did you learn from part A, Gio?
Set the integral I didn't like. I thought I was asking something different.
Okay. So you didn't even try doing an integral?
I didn't do an integral at all. Yeah.
Okay. Yeah. So knowing that just the profit is the integral. What about Stego? Same. Okay. Cool. So we're learning that. Claire, how'd you do on part A?
I got the integral part right because I knew that I was supposed to do an integral, but it didn't really make sense to me. Because, like, I don't know, the way I was thinking about this is you automatically know how much it's going to cost, so that you just plug in 25 for X. Like, on the 6 times the square root of X, that's, like, my thinking, and I don't really understand why we have to do the integral of that.
Okay.
Because it's just saying that's how much it costs to produce it. Right?
Yeah, 6 square root of X dollars per meter, and
Because if it's already talking about cost, you don't.
so the problem with that is that each meter has a separate cost. Like this, like if I think of a long 25 meter cable, the first meter costs a different amount than the second meter, than the third meter, than the fourth meter. So to account for all of these different prices of each individual piece of meter, you have to do 6 square root of X to each of these meters at an infinitesimal small point of range. And the only way to do that is with an integral.
Okay.
Yeah. And I agree, that is kind of a hard thing to realize and visualize. All right, so part B, using correct units, explain the meaning of this integral. So this is talking about the cost, right? So if I come down here, I can type my answer. I think size 18 is appropriate. So we'll say this is the total change in dollars from 25 to 30 meters. And then just saying that is enough to get you the full points, but if you want to be more exact, you can say from 25 to 30 meters for the cost of the, is it cable, right? Of the cable. So the key words that you're looking for whenever you have an integral, and this is from the speed sheet too, right? Total change. Total change, and then make sure that you have all of the correct units as well. So how do we score this one? Is a difference in costs of producing cable of length 30 meters and a cable of length 25 meters. This is still an okay way of explaining it. You'll get full points for this. So total change from 20 to 35. And it says, it uses the word difference instead of total change. It's the same word, change and difference. From 30 to 25 meters, and then they said in dollars, so we said in dollars as well. We get all of our units correct. We said total change, you get yourself +1. That's just out of 1 point. Questions about part B? Part C, write an expression involving an integral that represents Mighty's profit. And it defines profit in the parentheses up here. Note, profit is defined by the difference that you receive minus what you have to spend, right? So it's basically saying you do the positive rate minus the negative rate. So I'm going to do an integral. Do we have any starting amount? Starting amount? No, yeah, there's nothing. So I'm always thinking of this one as start plus change is equal to n still. So I'm going to do 0 plus the integral from 0 to, we don't know how long it is, so I'm going to leave it k. So 0 to k of the positive one minus the negative one. So the positive one is, I'm making $120, so $120, and then I have to subtract 6 square root of x, and that's all dx.
Isn't DK?
dx, I think, because your equation was still like up here, 6 square root of x dx. Usually these are different letters, as Ara was talking about in our last lesson, and this is a case where that is true. That's all we need to write. So let's go ahead and see what is it's saying. It writes it slightly differently because it can actually simplify this one, but that 120 can be on the inside, and you can just use our shortcut to find that. And we get 1 point for the integral, 1 point for the expression. I guess the way that, since it uses 120k, you'll still get the points by writing this. So I'm going to give you 1 point for having the 120 and 1 point if you have everything else. So this is going to be out of 2 points.
So what happens if I didn't put a 0 plus?
If you didn't have the 0 right here,
Yeah.
full points. 2 out of 2.
Well, I didn't like write it completely like that. I put like brackets.
Uh, Brackets around,
Yeah, like inside the parentheses.
like right there.
Like inside the one. Like right here. I put brackets right here. I don't know, that's
So instead of parentheses, you put brackets.
Oh, brackets instead of parentheses. I see. Yeah, yeah, it's full points. It doesn't matter. And then find the maximum. Okay, whenever you see a maximum or minimum problem, it's going to be a table, and then you're going to be looking for your relative extrema values and your start and end values. So let's go ahead and make our quick table here. Table. Oscar, is that door locked or unlocked?
It's locked.
Okay.
Did 3D printer work?
It does. We printed out the first successful thing yesterday.
Oh, okay, that's good.
I'll show you pictures later if you ask.
Okay.
All right, yeah, so time t, we're doing start plus change is equal to our end. So we need to do a start 0, and we don't have an end time, so we don't have to have any last value here, but we do need to find relative extremas. Or an easier way of doing it is, what are our critical values? We don't necessarily need a sign change. It does help, right? You can just find all of your CVs, and you'll therefore find all your relative extremas as well, because you have to be a CV before you are a relative extrema. You have to at least touch the x-axis before you cross the x-axis, in other words. So how do I find that? Well, I have to set our expression here to 0. This is the positive rate minus the negative rate. If I set that equal to 0, then I'm finding, well, I'm really taking the derivative of that, really. I'm having trouble explaining it. I know that I set, I'm doing 120 minus 6 squared root of x, and I set that equal to 0 because this is the rate. Both of those are rates, those are primes. So if I set f prime equals 0, that's the definition of a CV. F prime equals 0, that's CV. Define a CV, set that f prime to 0, set this 120 minus 6 squared root of x to 0. So we have to do some math down here, and we'll say 120 minus 6 squared root of x. This represents the rate of your profit, and I'm going to set that equal to 0. The derivative is being set equal to 0, and I solve. So add 6 squared root of x to both sides, and I have, let's zoom in here so it looks a little bit neater when I zoom back out. So I have 120 is equal to 6 square root of x. Divide both sides by 6, and I get 20 is equal to square root of x. Is that right? No. 100, yeah, okay, so, and then I square both sides.
Wait, isn't it negative?
No.
Oh, no, because of
Oh yeah, I added the 6 square root of x on the other side. And then I square both sides. So square that side, and I get 400 is equal to x. So our other CV, and it is going to be a relative extrema as well, but it's also a CV. The other point that we need to check is 400. So you need to check those 2 points.
And then can't we just like use common sense? It's gonna be 400.
You could use common sense, but I highly recommend using the table because it's the same procedure over and over and over again. So we don't have any start value, so 0. And then our change is the integral from 0 to 0 of this 120 minus 6 square root of x. And this is going to be plus the integral from 0 to 400 of 120 minus 6 square root of x. And we actually have to calculate what that is, because it's asking what is the profit, not how long does it need to be. Obviously the end is, or the length should be 400, but what amount of money are they going to make? And the answer is you have to do the integral. So, and this is pretty clear here that integral from the same thing to the same thing is 0. But now I have to do the integral from 0 to 400 of this bad guy. So do I have that done anywhere? I did it from 0 to 25. I have to do the same thing. So I've already taken the antiderivative. Let's kind of skip to this step where I took the antiderivative. So when I take the integral from 0 to 400, and I guess I should zoom in again so I can have slightly neater work when I zoom out. 0 to 400 of 120 minus 6 square root of x. I'm going to do 6x to the 1/2. All of that dx. That's going to be equal to 120x minus, and it's going to be 4x to the 3/2. And you might be saying, wait, where did that 4 come from? And again, it's coming from up here. It's going to be 6 times 2/3 because I divide down by 3/2, and then 2 times 2 is 4. So I'm just kind of skipping to this step right now. Hopefully we're all okay with that. All right. And then from here, evaluation bar between 0 and 400, 0 and 400. Again, when we plug in 0, we don't have to worry about it. I just need to plug in 400. So when I plug in 400, I get 120 times 400 minus 4 times 400 to the power of 3 halves. And again, I have to do that 3 halves trick. So I take the square root of 400 first, which we know because I squared it already. So square root of 400 is 20. And then 20 to the power of 3. Oh, dear gosh. So that's 20 times 20 times 20. Is that 8,000? I think it's 8,000, right? 20 cubed. Let's check our work. 20 times 20 times 20 is the same thing as 2 times 2 times 2 and 10 times 10 times 10. 10 times 10 times 10 is 1,000. 2 times 2 times 2 is 8, so it is indeed 8,000. So this is going to be 8,000. Yeah, thank you for reminding me. I probably might have made that mistake. Minus 4. And then, okay, so 4 times 12 is 48. And add on the 3 zeros. 48 with 3 zeros. So 48 with 3 zeros minus 4 times 8,000 is, 4 times 8 is 32. So it's going to be, yeah, you're already ahead of me. 32,000 and 48,000. 16,000. They make $16,000. It sounds way more impressive with a cooler voice, and that is in units of dollars. Final answer and box it. And that happens when? That happens when they sell a 400-meter cable. So I'll say $16,000, and you can just type this in really quick. For 400-meter cable. And I really should make that font size smaller. That's like ginormous. Let's make that, I don't know, 14. Oh my gosh, computer, you got this. It's the lack of a graphics card. This is what happens. All right, let's move on to the next self-check if there are no more questions. Oh yeah, we should score this one. Thank you for reminding me. How do we score this thing?
4 points.
4 points, yeah. So as long as you tried setting the derivative equal to 0, then you get a point. So back over here, we set this equal to 0. So just this line right here gives you 1 point. Finding that k is equal to 400, so plugging this value into your table, that will give you 1 point. Answer and justification. So if you have your answer of $16,000, that's plus 1 point. And if you use the table to show that it's obviously bigger at $16,000, you give yourself 1 point for having a table. So that is going to be out of 4 points. So 4, 5, 6, 7, 8, 9. It is indeed out of 9 points. Go ahead and grade yourself like an AP grader would. And hold up number of fingers. What did you get? Hey, not too bad. That's kind of what we're shooting for, around the 3 range, right? So we're just going to get better and better from here. Okay? So what were like the takeaways of this one? If you could summarize the one thing, this is the main thing I learned from this self-check, what was it, Claire? Units?
It just confused me with the I thought it was just prices and everything got confused.
Okay. It was probably the fact that our bounds weren't time, but our bounds were like distance.
No, it was just the money thing that I was confused that you needed to take an integral to do that, and then I got confused about everything else. I don't think I need to take an integral, and then I was overthinking everything.
Okay. Sega, what was the main takeaway?
You needed an integral for the first one.
Say it
You
again.
needed an integral to the first one.
Okay, integral. And that kind of sets up everything else. And then Geo?
See, I messed up since the beginning. I didn't set the integral.
Okay.
Yeah.
Yeah, so if we're ever looking for a total amount, a total profit, total always means take the integral. Whenever you're in AP calculus, at least. All right, cool. That concludes self-check 8.1. We're going to move on to self-check 8.2. Give ourselves 10 minutes on the clock. I'll go ahead and unlock that. All right, so we have our amusement park ride. We know that it closes 8 hours later, so theoretically when it closes, we shouldn't have any people left in the park. Hopefully. We know that there are 700 people to begin with, so that is our start amount. And our start time is equal to 0, because that is our start time in Part A at least. We know that people are moving onto the ride at a rate of 800 people per hour, so this is a positive rate right here. A positive rate of 800 people per hour. And R of t, lowercase r of t, is the negative amount on which, wait, That I'm so sorry. That is not correct. The rate of 800 people per hour, while that is people moving onto the ride, onto sounds like a positive word, they're moving out of the line onto the ride, so that's actually a negative rate. Sorry about that. And then the positive rate is R of t. People entering the line is a lowercase r. And that r is represented by this graph up here. So think of this graph as people moving on, and then we have to think of 800 as moving off. Whenever this happens, whenever I have a constant amount and some other graph, I graph this constant amount on top of this graph. It will save us lots of headaches later down the line. So let's go ahead and immediately graph 800. There it is. It's just a flat line, constant line. And we can label that line. That line is our negative rate. Right here of 800. So remember how I said whenever you have a positive rate and a negative rate, make them into one equation? It's kind of hard to do with this one because I don't want to make a brand new graph, but at least I have both the graphs on there so I can see what's happening. So for example, if I have a height that's above the graph, or sorry, a height that's right here that's above this negative rate, if the positive rate is bigger than the negative rate, then I should be increasing. If I have a rate, this is the negative rate again, right? If the negative rate is now, sorry, this is the positive rate. If the positive rate is now below the negative rate, then that means that I have a decreasing amount. I just want everyone to understand the graph that I'm making up here. So this graph is the positive rate. This is the positive rate. R of t is the positive amount. And then the negative rate is just this flat line right here. Okay, so let's move on. How many people arrive on the ride between 0 and 3? Okay, this is just an area problem. So I don't even care about this line anymore. I'm only caring about from 0 to 3. So making let's make an orange line at time is equal to 3. Right here, I need to find all of these different areas. So how am I going to do this? I'm going to see, I see a rectangle there, and I can cut through that line as well. So I see two triangles, a giant rectangle, and another giant rectangle. So this is a 2 by 1,000 rectangle, so this is 2,000. This is a 1 by 800, so this is 800. This triangle in here is 100 because it's 1 by 400. So this actually is 400, then divided by 2 is 200 right here. And this is 200 as well, because they're congruent triangles. Did you mess up on the triangles?
Yeah.
Oh no. Do you understand why it's supposed to be 200 now?
Yeah, but I messed up since the beginning of the problem.
Oh,
I
no.
read it wrong.
Oh darn, okay. Everyone okay on these triangles? All right, so moving down here, we just have to add all those up. So I say the integral of from 0 to 3 of lowercase r of t dt is given by, you just add them all up and you get 200 plus 200, 200 plus 200 plus 2,000 plus 800. And 800 and 200 make 1,000. And then add another 2,000, you get 3,000, 3,200. So this is equal to 3,200. Our units are people. So between 0 and 3, 3,200 people are going on are arriving into the line because that's our positive rate. So far, so good. Okay. How to score yourself on part A? They do their computations like that, but as long as we label the graph, we'll get our points. So you actually get a point just for writing the integral. You have to write the integral. If you didn't write the integral, you unfortunately lost the point. So I get 1 point for saying integral, and 1 point for getting the amount. That's out of 2 points. We can do 2 points on the right-hand side since we have room over there. Next question, part B. Is the number of people waiting in line increasing or decreasing? Okay, so I have number of people. That's my box. Box is increasing or decreasing. This is from our speed sheet. That means I'm taking the derivative of the number of people, or I'm now looking at the rate of the people. Is that rate positive or negative? Well, lucky for us, I don't know why that always happens. We have a graph of all the rates right here, and we graphed the negative rate on this graph. So if I look at between 2 and 3, so between this interval from 2 to 3, right here and here, which one is higher, the positive rate or the negative rate?
Positive.
Yeah, so that's increasing. It's that simple. But it is as hard. It is. I say it's simple. I don't mean that to demean you guys, but it's like if you made the graph and you understand the graph, it's all you have to do is look at the heights. Which one is bigger, the positive rate or the negative rate? So you say something along these lines. You'll say increasing, because we say r of t in that interval, r of t on 2, 3, or we can say r of t is greater than 800 on 2, 3. That's, I think, all you have to say. Let's see how the scoring guide says it. Yeah, they say almost the exact same thing. R of t is greater than 800 between 2 and 3. And they also say that negative rate is 800. That's why we're choosing 800 here.
If you say r of t minus 800 is greater than 0.
That's beautiful. That also works. So here's your other way. I can say, or, the other way of writing this, or r of t minus 800 is greater, is greater than 0. And you still have to say, well, you don't really have to say on 2, 3 anymore, but it helps. They say it in the problem. Yeah, so either of those are a great way of explaining it. Plus 1 point just for the explanation with a good reason. That's just out of 1 point. And then for part C, at what time t is the line the longest? So I'm thinking of a maximum. Whenever we have a maximum problem, then I'm making a table of start plus change values, right? So here we go. Table, let's make a blue line for a table. I have t values here. This is going to be start plus change. That's going to equal our end value. And I don't need to make this line so long. I can make this shrink down. Okay, so obviously we want the start, 0. Our end value doesn't make sense to have our end value. I mean, you can include it, but you shouldn't have any people in line because the fair has closed, right? Or the amusement park ride has closed. So I'm not going to do the end value, but we need some other critical value. And if you made this graph to begin with, you'll notice that where they cross is at time is equal to 3. Therefore, I switch from a positive amount to now a negative amount, because the negative is now bigger than the positive at time is equal to, or past time is equal to 3. So 3 is the other critical value that you want. So come down here, t is equal to 3. And again, where did I find that? I set the equations equal to one another, and I don't really have an equation, but I graph both of them and find where they intersect. The intersection is going to be the critical value. All right, and I guess it would be kind of fun to check what that end time is. Like, we should get 0 here for the end time if we choose, it closes 8 hours later. So if I come down here and choose 8, we should be able to prove that this is 0, and if not, then bad things have happened. So I might as well just have it on there for fun. You don't need to do that for the AP test though. Okay, so our start amount, we set it up here. Our start amount is 700, so it's gonna be 700, 700, 700, and I'm going to add the integral from 0 to this time 0, plus the integral from 0 to 3, plus the integral from 0 to 8. And what's really happening in this integral? So I'm really doing the positive amount, so it's that lowercase r of t minus the 800, because I'm always leaving 800. So r of t minus 800, and I could even abbreviate this just lowercase r minus 800, but I'm being a little bit formal about it. So minus 800. And I have to calculate what these are. So this one is kind of straightforward. It's gone. It's just 700. This one should be 0. We'll calculate it later. Let's calculate what this one is. It's probably going to be the answer. The integral between 0 and 3. Oh, look, we did that. The integral between 0 and 3 for the positive r of t is 3,200. So if I come over here and do my scratch work, the integral from 0 to 3 of r of t is equal to, I just forgot that number, 3,200. And then I have to do the integral from 0 to 3 of 800, because I have to subtract that, right? And that's equal to 3 minus 0, our shortcut, times 800, times 800. 3 times 800 is 2,400. And then I have to subtract one another. So I do r of t minus 800, right? R of t minus 800. And 3,200 minus 2,400 is 800, right? Yes, I calculated that correctly. So this is 800. Oh, that's 800 right there is 800, but then I have to add 700, and that's going to be 1,500. 1,500. And let's try this one as well. So, and again, I'm doing too much work now. I don't need to do this. The integral between 0 and 8 of lowercase r of t. I need to find all this other area to figure out what's going on. This is another congruent triangle. So if I zoom in here, this triangle right here that I'm talking about is another 200. I have this rectangle shape right here. So 1, 2, 3 by 400. 3 times 400 is 1,200. And this is 2 by 400. That's 800 divided by 2 is 400. So essentially, I just need to add 400 and 200 is 600 plus 200 is 800. So 1,800. All of this stuff adds up to 1,800. So 1,800 plus the original amount that we found before, 1,800 plus this original amount before, and that's going to be 5,000. Is that right? Yeah, 5,000. So if I come back down here, that's going to equal 5,000. And then I need to find the integral between 0 and 8 of 800. Ooh, there's some mistake that I've made because 8 times 8 is 64. So this is actually 6,400. And that doesn't add up to negative 700. We should get negative 700 because 700 plus negative 700 is 0. So theoretically, our mistake should lie right here. What should this have been? Instead of 5,000, we should have gotten 5,100, right? Because that would give us 7. Yeah, so do we miss 100? Let's think again. 200, 1,200, 400. That adds up to 16, 17, 18. 18 add up to 5,000. What did we mess up? They didn't have any answers for us here. But yes, 1,500 was a right answer, and I'm wasting time trying to figure this out. But I'm really curious: are there a random amount of people that are left over? I can look at the key from last year, I suppose. 5,000 minus. Oh my gosh, I am so silly. Minus 6,400 is negative. Wait. Yeah, we did not come out with 0. That is super weird. There are negative 700 people in line. I don't know what that means. Because look, you're doing 5,000 minus 6,400. We haven't made any errors. If I subtract one from the other, that is going to be negative 1,400. And negative 1,400 plus 700 is negative 700. And that doesn't make sense in the context of the problem. So I wonder if that's just like an error on the AP creator's fault. But yeah, final answer, 1,500. And at what time does it happen? At time is equal to 3. So let's type in our final answer here. So longest at t is equal to 3 hours with 1,500 people in line. Cool. And then scoring ourselves, we've seen the scoring guide because I've jumped back and forth between them. Identify t is equal to 3. Well, we put that there clearly, plus 1. And then you have the number of people in line. So number of people in line, yep, we did that over there. And justification, our table justifies that. So plus 1 for the table. That is out of 3 points. And D, write but do not solve an equation whose solution gives the earliest time when there is no longer a line. So obviously it doesn't happen right at the end because we had a negative 700. So we basically just need to set our integral equal to 0. So we do start plus change, set that equals 0, and we're done. So start was 700 plus the change from 0 to we don't know. So we'll say 0 to r. No, 0 to, it's an expression of r. Lowercase r, again, is the function of our positive rate, right? Lowercase r is our positive rate. So the variable that we're going to solve for, earliest time t, there it is. Earliest time t of this integral right here. So lowercase r of t minus 800, that quantity in brackets or parentheses doesn't really matter, dt. Set that equal to 0, and that means that the number of people in line, which this represents, is equal to 0. And that's it. Okay, do we get that answer correct? Yep, 700, your initial amount, and then 0t. Okay, so they did minus 800. They simplified this a little bit. It's the same integral, and they just split up the integral and then applied our fancy shortcut to it. So you get 1 point if you said 800. So you get plus 1 point if you wrote the 800. You get 1 point for the rest of the integral, and you get 1 point. Oops. 1 point for, I'm guessing, this initial amount. Oh no, 1 point for the answer. You don't get any points for the 700 as long as you have, oh, I guess you do. You get 1 point for everything else that's not the integral. So I'll just say plus 1 essentially for the 700 and the fact that it's set equal to 0. So it's this 700 and that 0. And that's going to be out of 3 points. So 3, 4, 5, 6, 7, 8, 9. Yes, this is out of 9 points. Please have the correct number out of 9 at the top of your paper. And that concludes self-check 8.2.